All right, here we go. So this is problem 1.1 from the McIntyre Quantum Mechanics textbook. It's a really long problem, so I'm going to break it up into a few different videos. I'm going to do each state separately. So here's the first one right here. And there's 4 steps right here. We have to normalize this vector. We have to calculate the probability in each of the directions. We have to write the normalized vector in matrix form, and then do part B again in matrix notation. So quite a bit of things to do here. So let's get right to it. First, we're going to normalize this. We can normalize it by adding a normalization constant. So I'll make that C. And remember that if it's normalized, then if you take the inner product with itself, that should be 1 if it's normalized. So we would know that this would need to equal 1. So we can do this. So then the bra state here would be just to reverse this here. So first you need to take the complex conjugate of C. So C star, and then times, and then there's going to be the bra state here. So 3 bra of the plus, plus 4 bra of the down. And then we have our ket state. So right here, our ket state here, it's going to be the same thing as this. So we'll have C, and then 3 up, plus 4 down. All right, and then we can just multiply it together. So we have our C star C. And again, this is going to equal 1 here. And then so we have our 3 times 3 is 9. And we have an up and an up. I'll write all of these out for the first time here, in case you're new to this. So then we're going to just FOIL this. So then 3 times 4 is 12. And then we have an up and a down. And then we have our 4 times 3 is 12, and we have a down and an up. And then 4 times 4 is 16, and we have a down and a down. Okay, so first of all, we have our 1 equals C squared. And then our plus and a minus, that's going to cancel out. So basically, that's saying if we're in a plus state, if we set our system up in a spin up state and we measure it, what are the chances of getting a down measurement? And there's a 0 chance. That's never going to happen. So that's going to be equal to 0. And because of that, that gets canceled out. Alternatively, if we set our system up in a spin up state, what are the chances that we measure spin up state? And that's 100%. So this is going to be equal 1. So these will both be equal to 1. If we set our system up in a spin down state, what are the chances that we'll measure spin down? 100%. So then this is just going to become 9 plus 16. And then that's going to be C squared times 25. Divide both sides by 25. We have C squared is equal to 1 over 25. And then C is going to be equal to 1 over square root of 25 is just 5. So 1 over 5. And we'll take so that'd be plus or minus 1 over 5. But we'll take the positive. And then that's our normalization constant. So now to normalize this, we just multiply out that C. So that would be equal to 3 over 5 up plus 4 over 5 down. And now that is normalized. So that's part A. So now we have to calculate the probability of plus and minus for all 3 directions. So we'll start with the z basis. That's going to be the easiest. So if we do up with our state here, that's going to be our up bra. And then we're going to multiply that with our state here. So 3/5 up. And I won't write all this out every time, but starting off I will. 4/5 minus. You'll see pretty quickly that a lot of this is a little bit redundant. So if we multiply the plus and the plus, we're left with 3/5. Oh, I almost forgot. We need to square this also to get the probability. So this will all be squared. All right, so 3/5, and we'll get a plus and a plus. And then we'll have our 4/5 and a plus and a minus. And again, we know that this is going to cancel. And this is going to be squared. So we're going to have 3/5 squared, which is going to equal 9/12. 25ths. So a plus in our z direction is going to be 9/25ths chance. And we'll do this for the minus. So our minus, with our state here, is going to be our minus, and then our 3/5 plus 4/5 minus. And we know that our minus and our plus are going to cancel out. So we'll only be left with our 4/5 there, because a minus and a minus, that's going to be 1. So 4/5 squared is going to be equal to 16/25, which we could have guessed because the only other option, if it's not up, it's going to be down. So this is 9/25, so the rest of that is going to be 16/25. So the chance of it being down in the z direction is going to be 16/25. All right? So then next is going to be, let's go ahead and do the x direction next. So let's do plus in the x direction along with our state. Okay, so how do you do this bra in the x direction? So if you remember, our ket for the x direction, so plus x is going to be, so if we are oriented in the z basis, then what are the chances of us measuring a plus in the x direction? It's going to be 50-50. And if you remember, that was going to be 1 over root 2. This is normalized. 1 over root 2 plus, and 1 over root 2 minus, to give us a 50-50 chance of it being plus or minus. So that's going to be our ket for spin up in the x direction. So if we reverse that, our bra in the up direction for x is going to be equal to 1 over root 2, the bra up, plus 1 over root 2 down. All right, and then so we'll leave it right there for now, because that's all we need for right now. So that bra for up in the x direction is just this. So that's going to be equal to, let's write this out here, 1 over root 2 plus 1 over root 2 minus, and then our state here. So 3/5 up plus 4/5 down. Okay, so we have our up and our up, so that's going to be 1 times 3 is 3. Root 2 times 5, so let's, I'll write that 5 root 2. And again, it's going to be squared. And the, okay, so plus and minus will cancel out. The minus and plus will cancel out. And then we'll have the minus and minus, so that's going to be plus 4 times 1 is 4. 5 times root 2 is 5 root 2. All right, and again, we're going to square this. So because we have similar denominators here, we can combine that to be 7 over 5 root 2. Square that, and we have 49 over root 2 squared is 2. 5 squared is 25. So 25 times 2 is 50. So we have 49 out of 50. So that's going to be up in our x direction is going to be 49 over 50. So we can kind of assume that down is going to be 1 over 50. Should probably write that correctly. But let's go ahead and verify to make sure that that is correct. So down in the y direction, or down in the x direction, down in the y direction. Well, first let's do the ket. Let's do the ket for down in the y direction. Keep saying y. In the x direction equals 1 over root 2 up minus 1 over root 2 down. So the bra is going to be 1 over root 2 up minus 1 over root 2 down. Same thing. So far, things change a little bit in the y direction, but here we're going to have minus in the x direction and our state. Okay, so again, our bra right here, we wrote it out right here, is going to be 1 over root 2 up minus 1 over root 2 down. Inner product with our state here, 3 over 5 up plus 4 over 5 down. Our plus and our plus is going to give us 3 over 5 root 2. And our here, so we have a negative and a positive. That's going to be minus. So 1 minus, or negative 1 and 4 is going to be 3 over, that's a multiplication, not. So I mean negative 4 times 1, and then 5 root 2. Now I can do subtraction. So 3 minus 4 is going to be negative 1, so we'll have negative 1 over 5 root 2. It's going to be squared, so the negative is going to drop out. It's going to be 1 over 50. So our minus in our x direction is going to be 1 over 50. All right, did that. Now for the y direction. I'll write this again over here. So our plus in our y direction, if you remember, it was, what was it? I think it was 1 over root 2 up plus I 1 over root 2 down. Is that right? And then our, if we were to reverse that for our bra state, we have 1 over root 2 bra for up minus, because we need to take the complex conjugate of I, so I 1 over root 2 down. All right, so we have plus in our y direction, inner product with our state equals, okay, our y bra right here, we have 1 over root 2 plus minus I 1 over root 2 down. I didn't leave myself enough room here, so I'll just go ahead and erase those. We have 3/5 up plus 4/5 down. All right, so we got a plus and a plus, so we have 3 over 5 root 2. And then we have our down and a down, so we have minus 4I over 5 root 2. All right, so that's where things kind of get tricky now, because now in the denominator we're good, but in the numerator we're going to have 3 minus 4I. So we need to square this. So to square with an I, you need to square it with its complex conjugate. So it's going to be 3 minus 4I times 3 plus 4I. And then just FOIL that out, so that's going to be equal to 9. Outer product is going to be plus 12I minus 12I. So that'll cancel out. And then minus 16I squared. All right, so those will cancel out, and we'll be left with 9. It's going to be plus 16 because the I squared is going to be negative 1, so that canceled that negative. And again, we can't forget this 5 root 2 here. And actually, that's been squared already, so this should be now 50. All right, and then that's going to be equal to 25 over 50, which is equal to 1/2. So our plus probability in the y direction is going to be 1/2. So we should get 1/2 for our down also. So let's see if that's what we get. And then so lastly over here, we will write our down in y is equal to 1 over root 2 up. And I think this was still, all right, this is plus. I think this one was minus I 1 over root 2 down. But then when we take the complex conjugate of that, hope this is right, that's going to be 1 over root 2 bra up plus I 1 over root 2 down. And you can see the only thing difference between those two is just the sign here, and that's likely to just get canceled out when we square it. But let's go ahead and go through the motions here. So let's do 1 over root 2 up plus I 1 over root 2 down, and times our state here, 3/5 plus 4/5 down. We have a plus and a plus, so we have 3 over 5 root 2. We have our 4, and this is going to be positive, so plus 4i over 5 root 2. And that's going to be squared. So same thing as before. This is going to be 3 plus 4i, but then multiply it with its complex conjugate, which is going to be 3 minus 4i, which is the same thing that we did before, which we already know is going to end up being 9 plus 16, which is going to be equal to 25, and that's still over 50, which is going to be equal to 1/2. So that is going to be our probability of a minus in our y direction, is also 1/2. Whew, okay, so that's all the probability calculations. The next step for this is to write this out in matrix notation. So this normalized vector right here, write that in matrix notation, which would be 3/5 and 4/5. All right, and then so these would be, in matrix notation, would be 1 root 2 and 1 root 2. The bra, though, remember, that's going to become a row vector. So that's going to be 1 root 2, 1 root 2, like that. So same thing here. This is going to be 1 root 2, negative 1 root 2. And in our row vector is going to be 1 root 2, negative 1 root 2, and so on. So it's going to be 1. I could also pull out this 1 root 2, so then I could just write this a little bit nicer, but however you like to write it. And this is going to be I 1. I could just write it as like I over root 2, works also. And the row vector equivalent of it is going to, what did I do? Yeah, no, that's right. Okay. 1 root 2. And then this becomes minus I over root 2. And we have 1 over root 2, negative I over root 2, and then 1 over root 2, I over root 2. All right, so now that we have all those written out, we have this one written out, we can kind of do the same combinations here. So, and also just our normal z basis is going to be 1, 0, and our down is going to be 0, 1. Okay, so if we were to do our plus with our state, I don't think I'll do all of these. We did the math already, but I'll kind of show how this would go. All right, so our plus here is 1, 0, but in row column form, we do 1, 0, and then 3 over 5, 4 over 5, and then, so that'd be 3/5 times 1 is 3/5, plus 4/5 times 0 is 0. And again, we want to square this. That doesn't change. So we'd be squaring this equals 9 over 25. Same thing if we do with minus. Square it is equal to, that's going to be 0, 1. It's going to be this vector right here. And then 3/5, 4/5. It can be 0 plus 4/5 is 4/5. Squared is equal to 16 25ths. And And then maybe kind of just pick one from down here. Maybe I'll just pick the last one right here. So we have this 1 over root 2, I over root 2. So if we were to do down in the y direction and square it, that would be 1 over root 2, I over root 2, 3/5, 4/5. So then we would get, so 3/5 times 1 over root 2 is going to be 3 over 5 root 2 plus, again, we're going to be squaring this, 4 over 5 root 2. Did I miss an I somewhere? Yeah, this should have been an I right here. So that should be 4I over 5 root 2, and square that. And then 3 plus 4I times 3 minus 4I. That's going to give us our 9 plus 16, which is equal to 25, still over 50, which is going to be our 1/2. And you can do all these other ones the same way. So that is our first state, and I'll go through all of these steps again for the other two states in the next videos.